Now let's think about integrals and volumes for volumes again. So think about the following question. Let D be the quarter of the circle, or part of the disk enclosed by x squared plus y squared equal to 9. That's the circle, right? So it's a quarter of a disk of radius 3 in the third quadrant. Write the integral, write the double integral that computes the volume under the surface, fx, let's just say z equals to xy over d in both rectangular and polar coordinates. So in other words, I want you to write two double integrals. One double integral in rectangular coordinates, another double integral in polar coordinates, both calculating the volume captured under the surface over this domain D. Now we learned that to find the volume of the surface under the surface, you simply integrate this function over the region D that has the meaning of the volume enclosed under the surface. Just like how in one-dimensional case, if you integrate the function over some interval, it's the area under the graph over that interval. Right? So that's what we're trying to do here. However, we first need to think about how to express this domain D. So here's domain D of radius 3, and we're talking about this quarter circle, the one that belongs to the third quadrant. 1, 2, 3, 4, so that's the third quadrant. And the equation for that is x squared plus y squared equal to 9. And even for rectangular coordinates, there are actually two possible solutions. You can use dx dy, or you can use dy dx. So I'll just do the dy dx, and actually dx dy will be very similar to dx dy dx. So try to do that on your own. See what it would be. Okay. Let's do dy dx for the rectangular. And if dy is inside, that means you're increasing in the y direction. That means I'm painting this region upwards, right? Which means when you write this, you should be integrating this function xy, that's our function. This is the surface, the function that gives you the surface. And we're trying to do dy dx. And I need some equation that describes this curve, this quarter circle, and ends where? Ends here, right? I need something that ends there. So I need something that describes this one. I need something that describes that. And we're going upwards like that. Okay? And then how about dx? What's the minimum value of dx? Negative 3. And maximum? 0. Okay. So as soon as we figure these bounds, then we are done, right? Okay. And actually, one of them is easy. What's the equation for this one?
Y equals x. X equals y.
X equal to y is a 45
yeah.
degree. What?
Y
Okay, so don't say that, okay?
Oh, sorry.
All right. So you have y equal to 0. Ah, you just ruined it. The problem with saying such a thing is that